Okay, this is your homework number 2 for limiting and excess reactants. So let's start with number 1. I'm going to start some of them for you and you are going to finish them. Here's the equation that you have. And the first thing you always have to do, it says balance the equation for this reaction. Okay, is it balanced? It is not balanced. We have 2 hydrogen here and 3 here. So that means we have to put a 3 here and a 2 there. And that gave us 2 nitrogen, but we already had 2 nitrogen on this side, so we're all set. Putting a 3 and a 2 makes it balanced. That's the first part. Now part A. It says if 75.0 grams of nitrogen gas and 18.75 grams of hydrogen are used for this equation or this reaction, which reactant will be the limiting reactant? Show your proof. Okay, you've got to set this up just like we did in all the notes and in the homework yesterday. I set it up for you. So I want you to set this up and finish. Finish part A, find the limiting reactant, and then for B, find the excess reactant and how much is left over, right? That's what you're going to do for number 1. Number 2, they don't have the equation for you, so we're going to do it together right now. Silver nitrate and iron 3 chloride. So let's find silver and nitrate. And their charges are the same. So when we do this, we get silver nitrate, okay? And iron 3, which means it has a +3 charge, chloride, and we got chloride right here, which has a -1. So when we do this, we get FeCl3, okay? And it says, write the balanced equation for this double replacement reaction. So you got to remember what that means. Double replacement means that the silver is going to go with the chloride, chlorine, and the iron is going to go with the nitrate. So let's do that, the silver and the chlorine first. Silver is +1, chlorine's -1. So that's going to be AgCl. And then the other one, you always start with the one that is positive. So iron is +3 and nitrate is -1. So when we do that, we get FeNO3, 3. Okay? So let's rewrite our equation. I'm going to rewrite it on a new screen. We got silver nitrate and iron chloride make silver chloride and iron nitrate. Then the next step is it balanced? Well, we got 1 silver, 1 silver. We got 1 NO3. Oh, but over here we have 3 NO3s. So we're going to have to put a 3 here, which gave us 3 silvers, which means we'll have to put a 3 here. So we have 3 silvers, which gives us 3 chlorine, but we have 3 chlorine and we have 1 iron on both sides. So that is balanced. This is part A right here, your balanced equation for the double replacement. Part B, determine the limiting reactant. Okay, you start with what you have. You have 27.0 grams of silver nitrate, and you have 43.5 grams of iron chloride. All right, that is what you are starting with. You put this over 1, you go ahead and you set this up, and you get at the end what you need. Okay, this first equation will tell you what you need for iron 3 chloride, and the second one will tell you what you need for silver nitrate. And then you're going to compare what you need to what you have and see which one is the limiting reactant. You're going to do that. Then you're going to do part C. Using the limiting reactant, calculate how many grams of silver chloride. What is silver chloride? AgCl. So you're going to start with whichever one is the limiting reactant. You have to do part B before you can do part C. And then you're going to do part D, which is just finding how much excess you have with the excess reactant. Okay, so far you have basically 2 problems to do. And I'm going to give you one more. This last one, number 3. A double replacement reaction occurs between 2 solutions of lead to nitrate. All right, so we got lead 2, it's got a +2 because it told us that, and nitrate. Nitrate has a -1. So when we do this, we get, I'm going to do it down here. Okay, there's lead 2 nitrate and potassium bromide. Potassium and bromide +1 -1, so that becomes KBr. All right. And it tells us that it's a double replacement reaction again. That means that the lead is going with the bromine. So now we have Pb +2 and bromine -1. So when we do that, it becomes, I'll do it in the same color, it becomes PbBr2. And then the potassium, start with the positive, goes with the nitrate. They both have 1 charge, 1 positive, 1 negative. So that becomes, oops, I'll do it in blue. That becomes KNO3. Okay, now we got to balance it. Is it balanced? 1 lead, 1 lead. Lead is balanced. Uh-oh, look at this. We got 2 nitrates and we only have 1 over here. So let's put a 2 right there. So that gave us 2 potassiums, which means we better put a 2 here. So we have 2 potassiums, which gave us 2 bromine, but we already 2 bromine right here, but we have 2 bromine over here. So I think we're all set. Okay, this is your balanced equation for number 3. Now you're going to do just what we've done. That's part A. This part A, I did it for you. Part B. If this reaction starts with 32.5 grams of lead nitrate and 38.75 grams of potassium bromide, how many grams of the precipitate will be produced? Okay, the precipitate is this. Okay. This is the precipitate. So this is what this is precipitate. This is what you're looking for. How many of that? So let's go to a new screen. Let's put our equation up here again. NO3 2 plus 2KBr PbBr2 plus 2KNO3. All right, so for part B, you're going to start with what you have. we have 32.5 grams of PbNO32. And you're going to do all this part until you find what you need of KBr. Then you're going to do what you have of KBr, which is 38.75. And you're going to do all of this, and you're going to end up with what you need for this. And then you're going to compare these and see which one is the limiting reactant. Once you find the limiting reactant, if the limiting reactant is KBr, then you're going to start with this to find the next part. If the limiting reactant is PbNO32, then you're going to start with this to find the next part. So whichever one of those it is, you're going to start with, and you're going to change it to moles, and then you're going to change it to moles of lead bromide, because that's what we're looking for. How many grams of lead bromide does it produce? Does the limiting reactant produce? So you got to decide which one of those is the limiting reactant first. And then you're going to do C, and you're going to find the excess. Okay, that's always the easy part because you're just subtracting. All right, I set them up for you. I gave you a lot of hints. I want you to finish this homework.